Question is, why do gases why do gases always tend to be less soluble in liquids as the temperature is raised? So first of all, when gas is dissolved in any solvent to form solution, heat is released. The reaction is exothermic. So we can write that dissolution of gases in liquid is always an exothermic reaction. Okay, it is always there. Whenever gases are dissolved in any liquid, reaction is exothermic, and exothermic reactions are favored at low temperature. Exothermic reactions are favorable at low temperature. So as temperature is raised, equilibrium shifts backward. Equilibrium shifts backward. That's why gases tend to be less soluble in liquid as the temperature is raised. So the equilibrium shifts backward. So this is the reason, because you rightly said dissolution of gases in liquid is always an exothermic process, and exothermic reactions, exothermic processes, they are favorable at low temperature. Okay. Question number 11. Now, question number 16. Heptane and octane, they form an ideal solution. See, first statement. From this statement that heptane and octane, they form an ideal solution. So what it reflect? What it reflect? Heptane and octane form an ideal solution. So it follows which law? In solution, which law is followed by ideal solutions? Yes, beta. Which law is followed by ideal solutions? Just tell me. Which law is followed by? Very good, Rawls law. Ideal solution follow Rawls law. So first statement tell us that Rawls law is used to solve this question. Now at 373 Kelvin, vapor pressures of the two liquid components are given. That means P naught, let us say heptane as A, and octane as B. Okay. A is heptane and B is octane. Okay. Now, what will be the vapor pressure of the mixture? So we have to calculate vapor pressure of the mixture when we have 26 gram of heptane and 35 gram of octane. So tell me, what is Rawls law? According to Rawls law, PA equal to P naught A XA, PA equal to P naught A XA, and PB is equal to P naught B XB. Am I right? The formula of Rawls law, that PA equal to P naught A XA, PB equal to P naught B XB, and P, that is vapor pressure of the mixture, that is equal to PA plus PB, that is P naught A XA plus P naught B XB. Now you know XA plus XB, that is equal to 1. So from here XB or XA is equal to 1 minus XB. Okay, so in this way P equal to P naught A 1 minus XB plus P naught B XB, right? So in this way P equal to P naught A minus P naught A XB plus P naught B XB. Okay, so P is equal to P naught A plus P naught B minus P naught A into XB. So this is according to Dalton's law of partial pressure, that sum of the total pressure is sum of the partial pressure of each component, right? In case of gases, and here in case of solution, total pressure of the mixture equal to pressure of vapor pressure of A and B, sum of the vapor pressures of A and B in the solution. So now what we need? We need P naught A, that is given to us. What else is required? P naught B, again given to us. P naught A and P naught B are given to us, but what is not given, that is XB. So from here question starts actually. XB we have to calculate. Now what is the formula of XB? Just tell me, what is the formula of XB? XB equal to, oh, that is okay, XB or XA. We need both. If we see XB equal to 1 minus XA, okay, XB equal to 1 minus XA, but XA is also not given. XB, either XB or XA, both are not given to us. So at least one we should calculate. Now, you know, XB equal to, do you know this formula? NB upon NA plus NB, right? Mole fraction of B equal to number of moles of B over total number of moles. So now number of moles of B and number of moles of A, they are required to get XB, but NB and NA are also not given. So we further solve it. What is NB? WA over MA, and NA WA over MA, right? Now WB equal to NB equal to WB over MB. So now WA and WB are given to us. See, P naught A, P naught B is given, WA, WB is given. So what is not given? That is MA and MB. So MA, that is molar mass of heptane. And what is heptane? C7H16 and Mb molar mass of octane. That is C8H18. So C7, 12 into 7 plus 16 into 1. 16 hydrogens and 7 carbon. 84 plus 16. That is 100 Q or 100 gram per mole. That is molar mass of heptane. Now come to octane. It is 8 into 12 plus 18 into 1. Okay, plus 18, that is 114 or 114 gram per mole. So now we need MA, that we have calculated. We need MB, we have calculated. We need WA. Now we revert, we go back. First we calculate Na, then Nb, then from these two Xb, then P. So go back. First Na. What is Na? Wa over Ma. What is Wa? Wa is given to you. Wa is 26 gram. 26 gram divided by its molar mass 100 gram per mole. That is 0.26 mole. Ma is 0.26 mole. Now Nb, Wb over Mb. So Wb is 35 gram over 114 gram per mole. So 35 over 114. It is 0.307 mole. Or we can write it as 0.31 mole, but let it be 0.307 mole. So from these two, let us calculate Xb. Just go back as such. Na, Nb, now Xb. Xb is Nb over Na plus Nb. What is Nb? It is 0.307 divided by 0.26 plus 0.307. 0.307 divided by 0.26 plus 0.307. That is 0.567. So 0.307 divided by 0.567. That is 0.54. 0.5414, but take it as 0.54. Now we reach up to this. Now we calculate P. So P is equal to P naught A plus P naught B minus P naught A XB, right? So what is P naught A? P naught A is 105.2. 105.2 plus what is P naught B? It is 46.8 minus 105.2. into 0.54. Now it is 105.2 plus 40, 105.2 and 46.8. It is minus 58.4 into 0.54 multiplied by 0.54 comes out to be 31.536. Comes out to be 73.664 kilopascal. This is the total vapor pressure of the mixture. Yes, beta, did you understand? So how do we approach the question? Got it? First, heptane and octane, it is given to us that it is form an ideal solution. So here we get an idea that it follow Raoult's law. Then vapor pressures of the two liquid components are given. Pure liquid, P naught A and P naught B. We take first one, heptane as A, octane as B. Then we have to calculate vapor pressure of the mixture. So vapor pressure of the mixture, just use this equation. P equal to P naught A plus P naught B minus P naught A XB. When we write this equation, that for the total vapor pressure of the solution, we know P naught A and P naught B are given to us, but XB is not given. Instead of XB, masses of A and B are given. So we convert first XB into number of moles. So XB in mole fraction in terms of mole is number of moles of B upon number of moles of A plus B. But number of moles are also not given. So we further convert number of moles in terms of weight. So number of moles of B equal to weight of A divided by molar mass of B. Sorry, number of moles of B equal to weight of B divided by molar mass of B. Number of moles of A, weight of A divided by molar mass of A. So at the end, weights are also given, but molar masses are not given. So we convert them into, we calculate the molar masses and then go back. Right? Yes, beta. Now, next question. Let's do question number 36. Same type of question. 100 gram of liquid A having molar mass 140 gram per mole was dissolved in 1000 gram of liquid B having molar mass 180 gram per mole. Vapor pressure of pure liquid B was found to be 500 To calculate the vapor pressure of pure liquid A and its vapor pressure in the solution if the total vapor pressure of the solution is 475 To. So just write what is given to you. First of all, just write what is given to you. So what is given to you? WA is given to us, that is 100 gram. Molar mass of A is also given to us. Rate of B is given to us. Molar mass of B is given. So now what we have to calculate? Okay, P naught B is given to us. but P naught A we have to calculate. And vapor pressure of the total vapor pressure of the solution is given. That is 475 So, yes, beta. Let me know what is the plan. How do you calculate? Yes. How do you calculate? Yes, beta. How do you calculate? First of all, yes. Try at your end. First, we will write the formula for the total vapor pressure of the solution. So, according to Dalton's law of partial pressure, total vapor pressure of the solution is P naught A plus P naught B minus P naught A XB. Now see, P is given to us, P naught B is given to us, P naught A we have to calculate, but XB we need. At least calculate P naught A. What else are given we have to know. So P naught B is given. See, this is required, P naught B is given. P is given, but XB we have to know. So to calculate XB, just go like the previous one. XB equal to NB upon NA plus NB, right? But NA and NB are not given. So we expand it further. You know, NB equal to WB by MB and NA equal to WA over MA. WA and WB, they are given to us. Okay, I write WA for both. WA 100 gram and WB is, okay, WA 100 gram, WB 1000 gram. They are given. But MB and MA, that are also given. Okay, so go back now. Calculate NA. NA equal to 100 over 140. 100 divided by 140. 0.714. NB, that is WA, WB over MB. 1000 over 180. 1000 over 180. So 1000 over 180, it is 5.555. That is, take it as 5.56. So X B equal to NB. NB is 5.55 divided by 0.714 plus 5.56. So 5.56 plus 0.714, 6.274. 5.55 divided by 5.56. Okay, 5.56 divided by 6.274 is 0.886. So XB we know now. So just put the values. A is 475. P naught A, we have to calculate. P naught B, it is 500 minus P naught A into 0.886. So it is 475 equal to P naught A plus 500 into 0.886 minus 0.886 P naught A. This way, 500 into 0.886 comes out to be 443 is 1.1 minus, it is 443 and 1 minus 0.886, that is 0.14114 P naught A, right? In this way 0.114 P naught A is equal to 475 minus 443. Now 475 minus 443, that is equal to 32. So P naught A equal to 32 upon 0.114. So it is 280.7 and answer is in 2. So 280.72 is the answer. Yes, beta. Just check the answer. Is it okay? 36th question is 280.72. Did you understand? Any doubt in it? Yes, beta. Very good, Kayur. 280.7. What? How? Yes. PA. Yes, yes. Next part is to calculate PA. So PA, that is vapor pressure of A in the solution. So it is P naught A, XA. Now XA is not given, but XB we have calculated. So XA is equal to 1 minus XB. That is 1 minus 0.886. Because XB is, so it is 0.114. That is XA. So it is equal to 280.7 minus 3 into 0.114. So 280.7 into 0.114, it is 31.9998. That is round about 32. 31.9998. That is very close to 32. So it is 32 toe. P naught A means vapor pressure of pure component A is 280.72 and vapor pressure of A in solution, that is 32 2. This is example 2.12. 2 gram of benzoic acid dissolved in 25 gram of benzene. It shows a depression in freezing point equal to 1.62 Kelvin. Molar depression constant for benzene is 4.9 Kelvin kg per mole. So what is the percentage association of acid if it forms dimer in solution? So see, let us start with the answer. What is the percentage association of acid? See, alpha is, let us say, it is degree of association. So this alpha is related to Van Hoff factor, because see, alpha we have to calculate. So to calculate alpha, the formula used is I minus 1 upon 1 by n minus 1. I minus 1 divided by 1 by n minus 1. This is for degree of association. And for degree of dissociation, formula used is I minus 1 upon n minus 1. Okay. Now, say n is given to if it forms dimer in solution. That means benzoic acid, it forms dimer in solution. How do it forms dimer? Whenever solution is non-polar, there is intermolecular hydrogen bonding, and it exists even in the vapor phase. It is like this. There is a very strong hydrogen bonding between two carboxylic acid molecules in non-polar solvent. So you know benzene is non-polar solvent, that's why it undergoes association. Now n for this is 2 because it forms dimer, so n is 2. N is given to us, but I is not given. So next part is, first part was I, alpha, and to calculate alpha we need I. Okay, calculate I, but we use, you know, depression and freezing point is there. Question is of depression and freezing point, and delta TF is equal to IKFM. Is the formula. In this, delta TF is given, shows a depression in freezing point. Delta TF, it is given to us. What is delta TF? 1.62 Kelvin. Okay. Now, next, weights are given. KF is given. Yes. KF is 4.9. KF is 4.9 Kelvin kg per mole. Okay. Delta TF is given, KF is given, but small m is not given. What is small m? Molality. Molality is not given. So now we convert molality. It is means it is further expanded. So molality is equal to weight of solute over molecular weight of solute into weight of solvent in gram into 1000. Now you know WB is given to us. What is WB? 2 gram. Benzoic acid. Solute is benzoic acid. WB is 2 gram. And what is WA? That is benzene. 25 gram. 25 gram. So now we go back. WB and WA is given. Rest is MB, molar mass of benzoic acid. MB, molar mass of benzoic acid is 6 carbon, 6 hydrogen, sorry, 7 carbon. This is H5COOH. 7 carbon, 6 hydrogens, and 2 oxygens. So it is 84 plus 6 plus 32. So 122 U, or we can write it as 122 gram per mole. Okay. So now we go back. Now everything we have to get I. Okay. So first we calculate small m. Okay. So small m, that is molality of the solution. See, how do we proceed? First we start with what is to be calculated. We have to calculate alpha, that is percentage association of acid. So to calculate alpha is percentage, so multiplied by 100. Formula is I minus 1 upon I minus 1 upon n, 1 by n minus 1. Now see, in this case n is given because it forms dimer. So as it forms dimer, so n is 2. So what is left? I. So I is not given to us. So to calculate I, we use this formula delta TF equal to I KFM. But here delta TF is given, KF is given. But delta TF is given, KF is given, but small m is not given. So we further expand it. Small m. We expand small m. Just to expand small m, it is like this. This is the formula used. So as this formula contains WB, MB, WA. WB and WA we have, but MB we don't have. So MB we have calculated because it is molar mass of benzoic acid, molar mass of the solute, and that is 122 gram per mole. Now everything we have. Now we go back. First we calculate small m, then we calculate I, and at the end we calculate alpha, that is percentage association of the acid. Just calculate small m first. Put the values. WB 2, MB 122, WA 25 into 1000. So it is 2000 divided by 122 divided by 25. It is 0.656. This is the first part. 0.656 mole per kg. Now after calculating molality, now we calculate next, that is I. So you know delta TF equal to I KFM. So I is equal to delta TF upon KFM. What is delta TF? 1.62. KF is 4.9 Kelvin kg per mole into M, that is 0.656 mole per kg. I is equal to 1.62 divided by 4.9 divided by 0.656. It is 0.504. So I is 0. I is 0.504. Now, after calculating I, what is left? Alpha. Just use the formula. Alpha equal to I minus 1 upon 1 by n minus 1. 0.504 minus 1, 1 by 2 minus 1 into, because you have to calculate percentage. So multiplied by 100, 0.1 minus 0.504. 0.496 upon 0.5, minus minus cancel, is alpha is equal to 49.6 by 0.5. It is 99.2%. It is 99.2%. Yes, beta, did you get it? Any doubt? I has no unit, okay? Just calculate it. When we calculate I, see, it is Kelvin. So Kelvin per Kelvin cancel, per mole cancel, Kelvin cancel. So I has no unit at all, because I is ratio of molar mass, ratio of qualitative properties, like that only. Okay. Thank you all. I love that you people support me, my channel, support me. You know, I'm going to solve each and every question of NCRT or CBSE board exam along with concept for class 11 as well as 12, and then NEET and JEE questions. Thank you so much with me and support my channel. God bless you all.